Well, thank you very much. Good evening from Guatemala City, and thank you, UNISEC, for the invitation. My name is José Bagur. I am from the Aerospace Laboratory at Universidad del Valle de Guatemala. In the next minutes, let me show you not just a satellite, but what one KiboCUBE opportunity turned into for an entire country, basically. So let me start where we began some years ago because to many of you it may look familiar. Guatemala had never built or operated a satellite before. At our university, there was no design experience, there was no flight heritage, and there were no test facilities. Our team was mostly undergraduate students, and every subsystem had to be learned and built from zero. Um, but then there's a key point, something that happened. Um, we won the KiboCube the second round in 2017, and that break a big barrier for us. A university team with enough determination can design, can build, and can test a CubeSat, but it cannot do on its own is to reach orbit. So that was the thing that KiboCube removed exactly for us, that barrier of going into orbit. And in 2020, we went with QUETZAL-1, the first Guatemalan satellite that you can see in the pictures. You can see the deployment from the International Space Station in 2020 and the delivery on the Tsukuba Space Center in Japan that was on 2019. Quetzal-1 was Guatemala's first satellite, 1U CubeSat, designed, built, and operated in-house at UBG in Guatemala City. Its payload tested a multispectral imaging sensor, and it was launched, as I said before, on the International Space Station on March 7th of 2020. And it was deployed from the Kibo module on April 28th, and it operated for 211 days. You can see in the images, you can see the mission patch that in Guatemala is quite famous, and it's a thing of proudness among Guatemalans. And you can also see one of the faces of the satellite in in one of the last times we saw the satellite here in the Earth before it was sent to Tsukuba and then launched it into space. So let me talk about a little bit of what we did with Quetzal-1. We built almost every subsystem of the satellite. Almost every part of the satellite was developed in-house. For example, the EPS that consisted on a six body mounted solar panels, three MPPT chargers, and LiPo battery. We also built the ADCS subsystem, that it was a passive subsystem with a permanent magnet plus two hysteresis rods. We didn't build the OBC, the onboard computer, and also we didn't build the receiver, the transceiver, the UHF transceiver, and the antenna. But we what we did was to write all the software, all the firmware that OBC needed to succeed to work. In terms of the payload for Quetzal-1, we developed in-house a multispectral imaging sensor that consisted of a piezoelectric motor rotating on a carousel with four bandpass filters that was meant to be used for water monitoring. And also we built from scratch using open source hardware and software the ground control station that has been recently improved and updated. Um, the results of Quetzal-1, I think the most important one is that it worked. We didn't have a lot of expectation, but it worked, and it worked like a lot more than we were expecting. On the some numbers, for example, on the deployment, the satellite was tumbling at plus minus 25 degrees per second in each axis, and within 1 week, the passive subsystem brought that down to 3.5. Also, the satellite aligned to the Earth's magnetic field to roughly 14 degrees, The power budget stayed positive the entire mission. The heater kept the battery from freezing. And we took the first images of Guatemala from space, from by a Guatemalan satellite. The bad thing about this is that when we took those pictures, there was a big hurricane in Guatemala on top of Guatemala. And after that, the satellite died. So we couldn't take more pictures of Guatemala, but we managed to take a few. And in those few pictures that we took, there is the two first images of Guatemala acquired from space. Um, so what else can I take? What are the lessons learned from Quetzal-1? Um, I will tell. Okay, about lessons learned, I was telling about documentation. Documentation is a system, not a deliverable. And that is particularly important in Guatemala because we are working with mostly undergraduate students. But the mission does not graduate. So we built a documentation system that specifically survives that turnover. The second one is commercial off the shelf parts. And if you are going to use commercial off the shelf parts in your satellite, you have to assume that they will misbehave. You can use commercial COTS components. They can absolutely fly, but they will fail in ways that the that datasheets never mentions. So fall protection is not optional. You have to take it in mind and you have to implement it to keep the mission alive. And the most important thing I think is the people. Don't forget that the satellite is not the product. The people are. The 211 days that Quetzal-1 was on space matter far less than the engineers this project created and the engineers that this project, that Quetzal-2, for example, and the projects in aerospace laboratory are creating. So that is the outcome that keeps paying off, and that is what is most important from all the things that we do. Um, Also, the program outlived the satellite. Quetzal-1 mission ended in 2020, in November of 2020. The Aerospace Laboratory was created that same year. And that means that now undergraduate students in Guatemala can work continuously on space technology, research, and development. That before Quetzal-1 and before the Aerospace Laboratory at UBG, that simply did not existed. None of that, I think, was planned on 2017 when we won KiboCUBE the second round. But it's an amazing outcome. Also, we are paying it forward to the community because we didn't build this satellite alone. We have a lot of colleagues and friends around the world that help us. For example, one simple example of Quetzal-1 is the ADCS, that it's based on the passive design that the CSSWE CubeSat at CU Boulder published. We could start our design because someone else had shared their work. So we choose to do the same. We publish everything, open source flight software, open source circuit schematics, peer review papers. Everything is published and is online for Quetzal-1, and also we are planning to do the same thing for Quetzal-2. So talking about a little bit about Quetzal-2, this brings me to the next satellite of Guatemala. Again, the access to orbit barrier was we removed that United Nations removed that barrier. This time with UNOSA's access to space for all through the XPOD initiative with Exolaunch, where we were selected as one of the four global winners. Quetzal-2 is a 2U CubeSat targeting a sun-synchronous orbit around 500 kilometers, built by a new generation of undergraduate students, and the delivery is planned for 2027. Right now is on December 2027, and it builds directly on Quetzal-1 flight heritage and hard-won lessons. Quetzal-2, as you can see, we have a conceptual prototype there. Quetzal-2 has three payloads. The first one is MILO, that is the acronym for Machine Intelligence for Layer Observation. In simple terms, it's onboard artificial intelligence that detects clouds in images, so the satellite only sends down the images actually worth transmitting. It runs on accessible COTS hardware with an onboard computer. We designed it ourselves also. It is still in development, but the idea is to show that meaningful AI can run on a satellite of that size. Also, we have a LoRa educational payload, a LoRa transmitter that will let students at secondary schools across Guatemala to build their own antennas and receive the satellite data directly. Um, and our main objective with this is to turn classrooms into ground stations across Guatemala. And the third payload is a in-house passive drag cell that safely deorbits the satellite at the end of at the end of the satellite's mission. And this is a commitment we made for keeping space sustainable with CubeSats. So this is passive it's a the orbit subsystem that the Quetzal-2 is going to have. We are you can see in that brief video how it works, and we are currently almost finishing the development of this subsystem in Guatemala. What is the team? Who is the team that is building Quetzal-2? It's predominantly undergraduate students again, and about 74% of the team are women. And that number is one of the most important results of this whole program that changed that the Quetzal-1 ignited, and this whole new generation of students that are developing space technology, and that makes us really proud and really happy in Guatemala City, in the whole Guatemala. So, some closing remarks. KiboCUBE did not launch only one satellite. It launched a national space program, and it changed a country. In 2017, we were a team and a country with no way to reach orbit. In 2020, we had 211 days in space and a laboratory. And in 2026, we have a second satellite and a new generation of students and researchers behind it. If you can take one thing from Guatemala's story, please take that the satellite is not the outcome. The capabilities that you build with it and the people you build with it is the important, the most important outcome. So thank you very much. Sorry for the technical problems, but I will be glad to ask any questions if you have, if we have some time. But also, I would love to stay in touch. So my contact details are here. Please don't be shy and write to us. We are open to collaborations. And yeah, thank you very much.